Hey environmental science students! In this lesson, you have a simulation of a quadrat study. Quadrats are a way of sampling an area. You can use them to estimate population abundance or the density of a certain species, but we're going to use this one to measure biodiversity using a special formula. The quadrat sample you see is randomized, so you'll see a different set of data than I do, but you can still use this to see how you would collect the data. First, you'll need to count all the species of each type in the quadrat. So the first thing in the table is crabgrass, and you can see crabgrass is this one. So I'm just going to count up how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and I'll put that down on my list. I'm just going to keep going like this. So I went ahead and counted all of those different species that I see in my quadrat study. You can see that for mine, dandelion came up as 0, so you may have some that are not present in your sample. And then we're going to fill in the n plus 1, or n times n minus 1, I should say. So this part here, what you're going to do is do 15 for this crabgrass, for instance. If there's 15 as your n, your number of individuals, that means your n minus 1 is 15 minus 1, which is 14. So you're going to do 15 minus 14, 16 minus 15, 14 minus 14 times 13, 9 times 8. That one I can do in my head, which is 72, but the other ones I'll pause and calculate before I go on. Okay, so now I have all of my n times n minus 1s. You can see that if you get a 0, 0 times, I guess, negative 1 is still 0, so you don't have to worry about that. But the numbers that are more represented get even a higher representation in the formula by multiplying them by those bigger numbers. So it just makes those ones that have a high abundance count for more. So then we're looking at our Simpson's diversity index. So what this formula is, it says 1 minus D is the Simpson's diversity index, where D is equal to this little thing, sigma. This means the sum of all the n times n minus 1s. So I will have to go back here and calculate out all of my n times n minus 1s added together. So I'll go ahead and do that. Okay, so I went ahead and added up everything from that first column and then everything from that second column separately, because we're going to need both of those numbers. When it asks for what is n, the total number of plants in the quadrat, that is this number. So that's the total number of all the plants. So if everything was filled up and none of it was dirt, each of those represented its own plant, you would have 100, because there's 100 squares here. But that's not always the case in every sampling method. So our n is 72. And so the n times n minus 1 is going to be 72 times 71, which is 5,112. So that is our denominator of that fraction. And the sum of all of the n times n minus 1s, that's what we had here. This was our sigma n times n minus 1. So we'll put that in 808 right here. And then the diversity index of this quadrat is going to be 1 minus D, or 1 minus, and then we have our sigma n times n minus 1. So on the top of the fraction is 808, and on the bottom of the fraction is this one, n times n minus 1, of all the total species present. So 1 minus 808 over 5,112. I'm going to make sure on this skill that it's set to need 3 significant figures for you to practice to make sure you do all of this correctly. But I have 1 minus 0.158, and that will be 0.842 to 3 significant figures. So it actually came out on my calculator without rounding it, 0.84194, but I would round it right here to the third significant figure. So at 0.842, that is the diversity index of this quadrat. And what that means is that's a number that's pretty close to 1. So this would be considered a habitat that has a lot of biodiversity. But that number by itself doesn't always mean as much as if you were comparing it. So what would be great is if you could go out to your school or to your ecosystem nearby and recreate this with real species. Do a quadrat study. You could just get something that's a square or a circle where you can count out species that are represented in a little area. And then you can do the same data collection that you see on the simulation and use that to try to decide if this has a lot of biodiversity or compare it to a different area. Create your own experiment where you could decide if one area has more biodiversity than another. And I hope that is helpful for you. Thanks.